Here we are at act.org, and from the homepage currently, you should be able to scroll down to the middle of the page where you will be able to access some online practice tests. As this video is concerned with the new online ACT version of the science section, you will recognize that the science section should be optional if you're engaging with the 40 question in 40-minute new 2025 science section. But you can scroll on down on this page. You'll have to scroll back past the sample practice questions because that is not the full section. Then you'll get to where you see full-length practice tests here in the middle of the page, referencing that starting in April 2025, this is going to be the new version of the online ACT. And as of the fall of 2025, even the paper version of the ACT will reflect these new section lengths and new section times. So for the purposes of this video, we will be engaging the science section. And the science section on the new ACT is going to be optional. It can be included in your overall score or not included in your overall score. But once we click on the science, you'll have a brand new window pop up. And you'll see if you're in the correct version of the new 2025 ACT Science section, there will be 40 questions referenced and 40 minutes. This is different than the Legacy ACT, which had 40 questions in the science section in 35 minutes. So you've got 5 extra minutes with the same number of questions. Now, you can take all the time you want here on this introductory page. The timer will not begin. And you can come to contrast and you can actually change the color scheme here if you're so inclined. We're going to stick to the default color contrast. And only when you are ready, click next, because as soon as you do, the timer is going to begin. You can see it's counting down on this instruction page. When you are ready, you can then move to the next question, the next slide, which is going to have the first question. Before you engage with the question, you'll want to select Tools up here, and you'll want to select Answer Eliminator so you can use the process of elimination, and you're going to want to select the highlight tool. I'm going to bring the highlight tool down just so it's out of the way, but we've got that selected so that I can actually highlight what I'm being asked to do for each of these questions and relevant information in the prompt on the left-hand side. So everything is going to be included in this scrollable section, but for the science section, you are going to want to determine what you're being asked for rather than reading the full experiment or charts and graphs, whatever it may be on the left-hand side up front. So we read the question stem first. It says, based on table 2, which of the following ratios best represents the number of times behavior 2 was displayed in habitat X compared to the number of times behavior 2 was displayed in habitat Y? So I'm going to highlight what I'm being asked to focus on and get straight to table 2, which I can see is right here. And we've got these behaviors 1, 2, 3, and 4. And we're comparing habitat X to habitat Y for behavior 2. And I can even highlight that right here. And I see that X is 3, Y is 6. So that is a ratio of 1 to 2. And that allows me to just move on to the next question immediately. Then we've got our next question, which says, which of the following observations for brown anoles were the same in both habitats Y and Z? So I'm going to just highlight brown anoles were the same in both habitats Y and Z, and I'm going to focus on this average perching height first. And I find that on the left-hand side here, and it's pertaining to figure 1. And we're talking about brown anoles, and I can see that's the little round circle here, and I see that the perching height is indeed the same for Y and Z, so I'm going to just highlight this for clear reference so I know that that is going to be the same, which allows me to eliminate any answer choices that do not have number 1 as part of it. So then we will move on, and we've got to consider just statement 2, because statement 3 clearly does not work just based on the answer choices that remain. So I'm looking for the number of times behavior 4 was displayed, and I can find that here down in table 2. And for Y and Z, they are different, so that allows me to eliminate choice C and select the correct answer of A. Now we'll move to the next question. It says, based on table 3, how many display times were measured for behavior 5 in habitat Z? So I'm going to go straight down to table 3. We find behavior 5. We're looking in habitat Z, and we've got brown, and then we've got the average. So none of these answer choices match the average, and it's true, I cannot determine what the number of display times was in habitat Z for a couple of reasons. One of which is we don't even have the same number, or the two different types of anole species. So we can select that as our correct answer and move on to the next one. We read, based on figure 1, for green anoles, the difference in average perching height between habitat X and habitat Y was closest to which of the following? So we're going to highlight that there, and we are in figure 1. We're looking for green anoles, so that means the square. And we can see between X and Y, there's a difference of 1.6 and 0.9. Now, you will not have a calculator on this section, but hopefully you can determine that 1.6 minus 0.9 is 0.7 and move on to the next question here. Then we've got a student claim that anoles are endotherms. Which of the following explains why this claim is incorrect? So it says anoles are endotherms, and we know that this claim is incorrect. And you may be thinking to yourself, I haven't read anything about endotherms. And so if we scroll down, we can see there's no real accompanying text in any of these tables or figures that we've been focused on so far. You may now finally have to read this introductory statement, which says green anoles and brown anoles are two species of reptiles, and they behave differently when the species are together in a habitat than when the species are in separate habitats. So now we know at least what a green and brown anole is. So now we can eliminate choices A and B because we know that these are not, in fact, amphibians. They are reptiles. And now we've got to think about what an endotherm might be. And this is the limited amount of external knowledge that might be required by the science section. So we know that a reptile, hopefully, is a cold-blooded animal. So a reptile would not generate heat from internal metabolic processes because it's cold-blooded. So that allows us to eliminate choice C. And then reptiles and, well, well, they are reptiles and primarily absorb heat. So I guess that's not technically something that would be wrong in the English section. But we can find the correct answer here with just that limited outside knowledge of knowing that a reptile is cold-blooded. And now we move on to the next question, which takes us to our next set of problems and our competing viewpoints structure here of 4 students. Again, I am not going to read this up front. I really don't want to, and I'm going to focus on the information on a question-by-question basis. So we read this next question. It says, which of the following diagrams best shows the location of the basal cavity as described by student 3? So I'm going to go straight to student 3, and we're going to focus on this idea of the basal cavity. Antarctic ice shelves melt only from below. During the summer, ocean currents circulate water that is just above freezing into and out of the basal cavity, the area underneath an ice shelf, causing the ice within the cavity to melt. Okay, so we might already have the information that's necessary. So I'm going to highlight that using the tool, and we know that the basal cavity, from our correct answer, should be the area underneath an ice shelf. Oh, well, choice A, we've got the basal cavity underneath the ice shelf. That makes sense. Here in choice B, we've got the basal cavity underneath the iceberg. That doesn't match what was stated. The basal cavity being on top of the ice shelf is a reversal of the information that was provided, and the basal cavity just kind of being offshore of the ice shelf also doesn't match. So we discovered what the correct answer is, and again, we don't read everything up front in the science section. Moving on to the next problem, we see, suppose that the air temperature along the Antarctic coastline is never warmer than -10 degrees Celsius and that the atmospheric pressure is always 1.0 atmosphere. Does this information support the description given by student 1? So we've got these 2 statements of fact that are added, and we're going to go just to student 1, who states, Antarctic ice shelves melt due to the warming of the air above the surface of the ice during the summer. When the air temperature increases, the surface ice melts and water cools. The meltwater moves downward into the ice shelf, causing fractures to form. The accumulation of many fractures in the ice over many summers gradually leads icebergs calving from an ice shelf. Well, we need the surface ice to melt according to student 1. And again, we need very limited outside knowledge for the science section, such as at what temperature does ice melt? Well, it has to get above 0 degrees Celsius. So we can eliminate choice A because that does not match what is happening in student one. So student one would not be correct. So it does not support student one, and ice cannot melt at those temperatures, which allows us to eliminate choice D and select as our correct answer choice C. Moving on to our next question. Based on the description of the icebergs that are calved along the coastline of Antarctica, do icebergs sink or float? Now, this is one of those situations where, again, if you have some basic outside science knowledge, you could be really fast at working through this because it doesn't matter whether we're on the coastline of Antarctica or not. It's whether or not an iceberg will float or not in the ocean, as it were. So we know from I mean, honestly, we saw it if we go back to our little diagram here. You can actually see that the iceberg, it floats in just the diagrams that have been presented. So if you remember that, you can actually get this answer choice or this answer correct almost immediately. But we know that ice is not more dense than water, so that's out. We know that ice is less dense than water, but that doesn't make it sink. Again, it's not more dense than water. We know that ice is less dense than water, which makes it float, as we saw in those diagrams, and we can move on to the next problem without, again, even engaging the information on the left. Next, we have which of students 1 and 4, if either, implied that the processes involved in iceberg calving will take more than 1 year to result in the formation of an iceberg. So we're talking about students 1 and 4 only, and we want to see whether or not it's going to take more than a year. So student 1 says that the warming of the air happens during the summer. And we keep on going. It says the accumulation of many fractures in the ice over many summers, which again, we can use the highlight tool to focus on, means that it is going to take more than 1 year to have many summers, so that's going to allow us to eliminate any answer choices that do not include student 1, so we can eliminate B and D. Then we move to student 4 and focus on whether or not that student believes it's going to take more than 1 year, and if we kind of skim through, we can discover that this student only references after several winter-summer cycles, so this student as well is going to believe that it's going to take more than 1 year, so we can select as our correct answer at this point, choice C. Moving on to the next question. In regard to the seasons involved in iceberg calving, how does student 2's description differ from student 3's description? Student 2 indicated that. This is a little bit convoluted, but I'm going to focus on the idea of the seasons, and I just need to go figure out what student 2 says about the seasons first off, and again, we can use the highlight tool to focus our attention on the relevant information. So we can see that student 1 is correct, that an increase in air temperature during the summer leads to surface ice melting and water pooling. So, okay, student 2 believes the summer is relevant. And then, however, the action of the meltwater alone is insufficient to produce fractures deep enough to cause calving when the air temperature lowers at the beginning of winter. Okay, so this student 2, believes that it's going to require both summer and winter phenomena. So summer and winter are involved in calving is true, not only summer nor only winter. So we can eliminate choices C and D for that reason. And now we just go to student 3 to determine what student 3 believes about the seasons. And we learned that student 3 says Antarctic ice shelves melt only from below during the summer and never mentions winter. So whereas student 3 indicated only winter is involved, no, student 3 indicated that only summer is involved. So we can eliminate choice B and select our correct answer of choice A. Moving on to the next question. Which of students 2, 3, and 4 agree with student 1 that some form of melting occurs on the ice shelf surface? Well, we probably already remember that student 2 said student 1 was correct, so we can eliminate anything that does not include student 2. Student 3 just said that shelves melt only from below, if we recall the prior problem, so we can eliminate anything that involves student 3. And then we just have to consider student 4, and student 4 says that snow accumulates on the surface of the ice each winter, but each following summer warm air leads to the melting and compaction of snow, which of course would be on the surface. So we can select the correct answer of choice C here and move on to the next of the science passages. Again, we are going to engage with the questions on a question-by-question basis rather than reading everything up front. And this question states, which of the following statements about the relationship between the number of A percula per tank and the average SGR is consistent with the results of experiment 2? On average, as the number of A percula per tank increased, so we're going to focus on just experiment 2, as the number of A percula per tank increased, what happened to the average SGR? So I'm just looking at the table. Stocking fish density, fish per liter. Well, we should recognize that 0.5 is less than 1, is less than 2, is less than 3. So this left-hand column shows that we are increasing as we go down. But we see that the average SGR goes down as the stocking density goes up. So as the number of A per kula, which if we were to scroll all the way up is our type of fish, well, as we get more fish, the SGR, whatever that is, and we haven't even really discussed it yet specifically, is going down. So as the number of A per kula goes up, the SGR goes down only. We select choice B as the correct answer, move on to the next problem, which states, which of the following statements about the protein diet in each diet and the average SGR is consistent with the data shown in the table and the results of experiment 1, the diet that resulted in the something. So we're just focusing on the table that is given above and the results of experiment 1. So we're focusing just on experiment 1 here. And we see that there's this diet QRST, and we've got these proteins and then SGRs. So I could see what we've got in the answer choices. We can actually use that to compare to expedite our evaluation. So highest average SGR is going to be diet S, and diet S does not have the highest protein up here, so we can eliminate choice A. Highest average SGR again was diet S, has the lowest protein. That's also not true. The lowest average SGR is going to be diet Q, and that does have the highest percent protein. And in the science section, if you find something that is correct, you may not even have to check all 4 choices because that is absolutely true, and that's a way to move a little bit more briskly through the section. Next, we've got, based on the results of experiment 1, if experiment 2 were repeated, except that all the A per kula were fed diet R, would the average SGRs more likely have been lower or higher for each group? So we're going to just look at the results of experiment 1 first, again highlighting for clear reference, and we can see that we're going with diet R. Diet R was 0.4 SGR. And down here, we can see that we find in experiment 2, the fish were fed diet T. And we know that diet T had an SGR of 0.35, which matches table 1 here. So that means that if it was fed diet R, we could expect reasonably that it would go up to 0.40. So both of choices A and B are going to be incorrect, and we can X them out because the SGR would not be lower. It would be higher and exactly 0.05% as we just identified. Again, you don't even really have to look at choice D and can move on to the next question, which states, suppose that in the experiments, 1 gram of food were added to each tank at each feeding. A total of how many grams of food would have been placed into an individual tank each day? So we're going to just highlight that. And we probably, for the first time, really have to read what's happening in the experiment. So it says that each of 12 identical 15-liter tanks received 10 liters of seawater having a salinity of 33 parts per thousand, a temperature of 27 degrees Celsius, and a pH of 8.2. Salinity, temperature, and pH were kept constant over the course of the experiment. A per kula of similar lengths were selected, and their lengths were measured in cm with a ruler. Then they were equally distributed among the tanks at a stocking density of 1 fish per liter. The tanks were then divided equally into 4 groups. For 4 months, each group was fed a different diet. Each group was fed the same mass of food 3 times daily. Okay, so we had 1 gram 3 times daily is 3 grams, and we are done. Can move on to the next question. Then we've got how many A per kula were placed in each of the tanks. So we're looking for how many A per kula placed in each of the tanks in experiment 1. We just got done reading this. We know there was a stocking density of 1 fish per liter. There were 10 liters. That means there were 10 fish, and we can move on to the next question. Which of the following was a dependent variable in experiment 1? So a dependent variable is whatever changed based on whatever independent variable was actively changed by the experimenter. We know that the volume of seawater in the tank, that was described as a constant. The specific growth rate, well, that's dependent on the food, and the food is the independent variable. Specific growth rate is the dependent variable. So we can eliminate the diet as the independent variable, and choice D, the stocking density, again, was a constant, so we can select B. And again, understanding what an independent variable versus a dependent variable is one of the very limited bits of outside knowledge you might need for the ACT science section. Next, we've got a new science passage beginning. It states in the question, where we begin as always, which of the of the samples in experiment 1 was most likely intended as a control for the concentration of vitamin C present in the unheated tomatoes. So we probably have to read a little bit in the introduction here to understand this. We don't really care much about this background information, but going straight to experiment 1, we see 2 kilograms of a particular variety of raw tomatoes were sliced and then blended in a food processor until a homogeneous tomato mixture was produced. The mixture was divided into 4 equal samples. Each sample was placed in a separate plastic bag, and the bags were sealed. The bag containing sample 1 was immediately frozen at 40 degrees centigrade. The bags containing samples 2 through 4 were each incubated in a water bath at 88 degrees Celsius for a different period of time, and then frozen at 40 degrees Celsius. So we can see that the time of the amount of time spent in the water is the independent variable. So we know that the one that doesn't go in to the heat, which is what we're ultimately testing, is going to be our control. So that means it's sample 1, which was just frozen and not heated up. Now we can move on to the next question. Based on the results of experiment 2, so we're going to go ahead and scroll on down to experiment 2, which of the following incubation times would most likely have produced a tomato mixture with a lycopene concentration between 5 milligrams per gram, or mg, I believe is milligrams, yeah, milligrams per gram, and 6 milligrams per gram? So we can just come to the chart. We can see that it's between sample 3 and 4. We know from what we just saw that samples 3 and 4 have incubation times in that heated water. And so 3 and 4 are between 15 and 30. So our correct answer here has to be 20 minutes. We move on to the next question. A student claimed that heating tomatoes decreases the concentration of nutrients present. This claim is consistent with the results shown for which of vitamin C and lycopene. So heating tomatoes decreases the concentration. So if we're looking at experiment 1, we can see and we know that the amount of time being heated increases through the sample numbers. 1 wasn't heated, 2, 3, and 4 were, and at increasing durations. So vitamin C as the y-axis variable certainly does decrease, so that eliminates lycopene only, and neither vitamin C nor lycopene. Then when we scroll on down to experiment 2, we can see that actually the frozen tomatoes had the least lycopene, and you get more lycopene as you heat the tomatoes, so it's not going to be both vitamin C and lycopene, it's just vitamin C only, and we move on to the next question. Here it reads, assume that in the experiments, the water bath contained pure water at standard atmospheric pressure, 1 atmosphere, while the bags containing the samples were being incubated. Was the water in the bath most likely boiling? Well, we know that the water bath was held at 88 degrees centigrade. Again, the limited outside knowledge you need. The boiling temperature of water, of course, is 100 degrees centigrade, so they would not boil. We can eliminate choice A and B. And of course, the incubation temperature was not greater than the boiling point for choice D, and we select the correct answer of C based on that limited outside knowledge that water boils at 100 degrees Celsius. Next, we've got in experiment 1, how many of the samples had a vitamin C concentration of less than 1 of the, I guess that's the micromoles per gram of tomato? And I don't even really need to know what a micromole is. I can use the measurement shorthand here on the vertical axis. But if we're careful, we can see that the top of the vertical axis is actually 0.8. So all 4 are less than 1.0 micromoles per gram of tomatoes. So that allows us to select the right answer. And we move on to the next question, which reads, consider the following procedures performed in experiment 2 for sample 2. These procedures were performed in what order? So sample 2 is one that was put into the water for 2 minutes at 88 degrees Celsius. And we can see the steps right here, kind of in between the 2 experiments. So it says that the sample was thawed and then we start with the samples 2 through 4 were incubated in a water bath at 88 degrees for a different period of time and then frozen at negative 40 degrees Celsius. And then these steps are going to be performed for each sample because experiment 1 was repeated in experiment 2. So we know that the first thing that happened for samples 2 through 4, of which sample 2 is one of them, it was incubated in the water bath. and then frozen. So let's just make sure we get incubated and then was frozen. So 2 should come first, which allows us to eliminate choices A and B. And then 2 comes first, then 1 comes second. So our correct answer is going to be choice C, because then the filtering comes last if we kept going. Just moving on to our next question and our next passage. We've got a linear region of a graph is a range of data that can be approximated with a straight line based on figure 1 for alloy Q, initially at a temperature of 550 degrees centigrade. Which of the following ranges of F best represents the linear region? We just go straight to figure 1, and we know we're looking at the dashed line for 550 degrees centigrade. And so we're just going to compare the answer choices to what's there in the chart. Between 0 and 10 by 10 to the 7th power, well, absolutely not. It's kind of like a parabolic function. We'll eliminate choice A for that reason. Choice B, 10 to the 7th and 20 to the 7th. Well, it goes up and then it goes down. That's not a line, so we can eliminate choice B. Then choice C, once again, kind of parabolic. Eliminate that between 20 and 30, 10 to the 7th degree, 10 to the 7th power. But then from 30 to 40, it's pretty much a straight line, and that's going to be our correct answer. Moving on to the next problem. Consider the 2 trends shown for alloy Q initially at the temperatures of 280 degrees Celsius to 550 degrees Celsius. So that means this figure down here. We've got from 40 times 10 to the 7th power and then 48 times 10 to the 7th power. If these lines were to continue along the same trend, at which of the following values of F would the average crystal length most likely be the same? So you're just going to kind of imagine what's happening with these lines, and you should be able to determine, it seems like somewhere around 60 they're going to intersect. So there's our correct answer, and if you're confident in your evaluation, and you can always trust these science graphic figures as drawn to scale, they're not tricking you here. You can just pick B at this point and move on. Next, we've got based on figure 1, which of the following combinations of values for initial temperature and F would produce the shortest average crystal length in an ingot of alloy Q? The smallest L would be produced with a temperature of. So I need the smallest L based on figure 1. There's a whole lot going on here, and I'm really just going to focus on the figure. So we know we're being asked about the smallest L. Well, L is the vertical axis, so it's got to be the 550 options, not the 280 options. So we can eliminate both A and B almost immediately. And now we're just going to track where it is. Again, on this figure, we can draw the scale, or trust is drawn to scale. So right here, it's about 92 at 10F times 10 to the 7, but it's just a little under 92 at 40. So our correct answer is going to be D, again, just by reading the figure without going into the details too much. Then the following table lists the mass of silicon in 50-gram samples of 4 different alloys, one of which is alloy Q. Given the composition of alloy Q, which sample is most likely alloy Q? And we can finally get into table 1 here. And table 1, we can see we've got the mass of silicon. Silicon is right here, and when we're looking at the way this is set up, the percent by mass in alloy Q means that 10.8 means that in 100 grams, you're going to have 10.8 grams that are silicon. So in 50 grams, you'll have exactly half of that, which is going to be 5.4. Again, there is limited math that you may have to do here without a calculator, but that hopefully is not too daunting as we move on to the next question. It states, based on table 1, if an ingot of alloy Q had a mass of 200, that ingot would contain what mass of Mg or magnesium? Well, again, percent by mass for magnesium is 0.22, so that means in 100 grams, you'd have 0.22 grams of magnesium. If you double that total to 200 grams, you're going to have 0.44 grams of magnesium in that ingot of alloy Q. Moving on to the next question and our next science passage. We're going to once more ignore reading it up front. We're going to deal just with the question and the task and subject as required. This one reads, based on the results of the studies, from which of the 5 leachets was the greatest percent of DOC absorbed by CM1, CM2, and CM3 respectively? Well, just kind of scanning this, I can see that figure 1 is CM1. And we've got DOC percent as our vertical axis. So I should be able to determine that's going to be pine. It's the highest bar. We can eliminate any answer choices that do not have CM1 as pine. Now we scroll on down where we see CM2. And this time we see that it's Magnolia. Well, each of these answer choices has Magnolia, so we've got to go to study 3. And for study 3, we see that the highest vertical axis variable is Magnolia once again, which allows us to choose choice D and move on to the next question, which reads, based on the results of study 3, the percent of leachate DOC absorbed by CM3 averaged across the 5 types of leaves is closest to which of the following? So we're going to just scroll on down to the bottom again. And I don't want to actually fully calculate this, but I should recognize that because the figures have to be drawn to scale, the average is going to be somewhere in between, like these two kind of tall ones and these 3 that are almost equal in maple, pine, and rhododendron. So that's going to put it somewhere around 40. Certainly not 10. It's certainly not 20. It's certainly not 30. 40 is going to have to be the closest, and it's just an estimation based on visual evaluation. As we move on to the next question, we've got, is the statement CM2 absorbed a greater percent of the DOC in the maple leachate than did CM3, supported by the results of studies 2 and 3? Well, one of the silly things you've got to do on this exam potentially is just frame things properly. So I'm going to just make sure I can see everything of study 2 and study 3 in one frame here so that I'm not scrolling up and down needlessly. So we want to see, is CM2 in the maple bigger in is DOC bigger in CM2 than it is in CM3 for maple? So we're going to look at maple. Well, maple's not higher in CM2 than CM3, so the answer has to be no. So we can eliminate both choices A and B as being basically backwards. And CM2 observed only 7, so choice C is the right answer, and we don't really have to even fully engage choice D. Next, based on the results of the studies, which of the 3 clay minerals, if any, reduce the DOC in the oak leachate by more than 50%? So we're looking at oak. Well, CM1 here is 30, so CM1 only, certainly not. Now I just have to look at CM2 only, and oak, certainly not. So it's got to be none, and this is kind of the way that the exam gets a little tricky, is if you are not careful, you'll talk yourself into choice or study 3 being true, but it's at 50, not more than 50. A little bit of a nuance that they can catch you on, but of course we've picked D confidently by this point, and we move on to the next question, which asks, is a mixture of any one of the leachates and any one of the clay minerals properly considered a solution? So we're going to highlight that. And we should recognize that a solution is when all of the elements dissolve in water. So that is what a dissolves out says here. So we've got to read about the clay minerals. And if we just read the opening paragraph, it says, in a lake, water leaches out, dissolves out soluble organic compounds from decaying tree leaves, producing dissolved organic carbon, DOC. Oh, we finally learned what DOC is after all those earlier questions we didn't really care. DOC is subsequently removed from the water if it is absorbed by, it becomes adhered to the surface of clay mineral particles that are suspended in the water. Oh, the clay mineral particles are suspended. That means that they don't ever actually dissolve. So, is this going to be called a solution? No, because we can eliminate choices A and B immediately because the clay mineral particles are suspended. They don't actually dissolve. So the clay mineral particles are dissolved. No, they are not. We can eliminate choice C for that. And of course, our correct answer is choice D, which states no, because the clay mineral particles are not dissolved in the leachate. And we can move on to the next question, which reads, in lake water, DOC is broken down into simpler compounds by electromagnetic energy in the visible wavelength range. Okay, so we'll just highlight that. It's certainly going to be important. What action was taken in the studies to prevent this process from occurring? So we've got to just keep reading that introductory statement. So it says green leaves were collected from 5 types of trees around the lake. We've got the list. We don't get to read them. A 5-liter volume of lake water was filtered to remove all solid particles. The following procedures were performed for each type of leaf. A 100-gram sample of the leaves was mixed with a 1-liter volume of the filtered lake water. The mixture was then placed in the dark for 10 weeks at 4 degrees Celsius while leaching occurred. Ooh, that very well may be the reason, because it's talking about in the visible wavelength range. At 10 weeks, the mixture was filtered to remove all solid particles. The resulting liquid was analyzed for that dissolved organic compound. So the key is recognizing it's talking about the visible wavelength range. So they were placed in the dark. That seems pretty good. You might check this if you're not certain of the relationship here, but it's not the mixed rate of the filtrate and the clay mineral. It's the mixture of the filtered lake water. So that's going to be eliminated there. And it's not about the filtering. So our correct answer is A, again, with just a little bit of synthesis of knowledge with kind of overall science information that you hopefully have learned in high school. Now we've moved on to our final science passage. We again read the question first, ignoring everything on the left. Consider the currents shown on the ammeter in figure 1 based on the results of experiment 2 when this current was measured. What was the relative intensity of the light? So we've got to pay attention to the current shown on the ammeter. The ammeter is right here. It says 19.8. We scroll on down to experiment 2. We match it to 19.8. So what's the relative intensity? It's 50%, and you can make this a lot easier on yourself if you don't try to read everything before attempting this question, but we'll move on to the next at this point. What aspect of the experimental setup was held constant in experiment 2, but not in experiment 1? So we've got experiment 1, which has all of these different colors, frequencies. We've got electron volts and electron volts. And experiment 2, we still have electron volts and we've got current, but we should note that it's the same setup except without a filter. So we've got to go figure out what the filter did. And the filter is what's going to be transmitting the color. So it's the color that was held constant in experiment 2, but not in experiment 1. Be careful, and you'll be able to proactively identify that. Next, we've got, based on figure 1, are the particles ejected from the metal plate moving toward the electrode or away from the electrode, and are those particles positively charged or negatively charged? So we just come to figure 1, we see the electrons, there's the metal plate. The electrons are being ejected toward the electrode. So we can eliminate the answer choices that say, we can eliminate the ones that say away from the electrode, and you'll note there's a little timer alert that pops up in 5 minutes. It's a good way to know if you just have to make sure that you put an answer for everything, but at this point we're probably okay. But again, coming back to this problem where we're being asked about whether the particles are moving toward the electrode or away from the electrode, well, it's moving toward the electrode. And of course, an electron is a negatively charged ion. So that's going to be the correct answer because we know electrons are negatively charged. And then we can move on to the next question, which states, based on the equation in the passage and the results of experiment 1, what was the value of M for the metal plate used in the setup? So we scroll on down, and actually we're going to start up top because we've got this equation, and the equation says that K is equal to E minus M. And so that means that M is going to be equal to K minus E. And so we've got to recognize why there is this asterisk. So it says that if there was no electron ejected, well, then there wasn't enough energy to get from the electron, and to get it off of the metal plate. So what that means is that our value of M, which we've just stated, is going to be equal to E minus K. Well, E minus K is going to be negative where we see the not availables. It becomes positive once it's 2.31. So 2.31, E minus K would be 2.2. So it can't be anything that's going to be greater than 2.2. So we can eliminate choices C and D. And if it were 2.14, well, then we wouldn't have an E minus K that's 2.2. And of course, there's 2.2 for all of these answer choices as well. So our correct answer is going to be B. And here we are at our penultimate question, which says, the cutoff frequency for a particular metal is the lowest frequency of light at which electrons are ejected from the metal. Based on the results of experiment 1, the cutoff frequency for the metal plate was, well, that's when the electrons start getting ejected. And they only become ejected in between the yellow and the green. So again, it's got to be between the 5.2 and 5.6 frequencies, which matches choice C proactively. And our last question of the set, we've got one more kind of pseudo math question. The relationship between E and the frequency of light is given by this equation, E equals hf, where h is Planck's constant and f is the frequency of light. Based on the data for green light in table 1. So I'm going to scroll down to table 1 and we're going to focus just on the green light here. And I can actually highlight in the table which of the following expressions could be used to determine the value of h. Well, h is going to be equal to E divided by f. So what's my E? My E is 2.31. Well, only choice D has 2.31 in the numerator of the fraction. Of course, we'd be dividing by the frequency f, which would be 5 times 10 to the 14 hertz. So our correct answer is D. You can select the index here to go back and make sure that you have answered all of the questions, and you can see here we have. And you can potentially also go back and address any questions that you may have flagged to return to. But for purposes of this video, we'll just go ahead and click next. We'll say yes, end the test. We will process our uploads for a moment, and ultimately we will see our results. Now, the thing to recognize about the results of these online practice ACTs at the time of this recording is that you will only be able to see these results once. You'll want to right-click and potentially either save them or print them. But also, if you did get something incorrect, it just says the result is incorrect. It doesn't give you any correct answer or the explanation. So it's a little bit of a challenge right now. Hopefully that's something that's coming in the future, and hopefully this video helped you as you prepare for the now potentially optional science section on the new online ACT moving forward in 2025 and beyond.